Right, welcome everyone. Anne Stothers speaking. Welcome to this Collins webinar. Thank you very much for joining. Just a reminder that this session is recorded and you will get a copy of the recording that will be sent out. Also that if you'd like to introduce yourselves, that would be fantastic. I'll just turn my camera on. Hello, there I am. So if you've joined, welcome, hello. If you can just put in the chat who you are, hello. Ramona, nice to see you. If you'd like to introduce yourselves, pop a line into the chat. I'm keeping an eye on that. Oh, Shirley, hello. And if you be very interesting to hear what school you're in. Rianne from PiXL School. Hi, Rianne. Lovely to see you. I'm hoping there's lots of teachers logging on. Mal, lovely. Jack from Peak Academy. Dawn, lovely, from Fleetwood High School. Stuart, working mental health. Hello, Daria. Nice to see you. Yeah, we'll give it a couple of minutes just for people to introduce themselves. Lovely to see so many of you logging on already, and then we'll get started. Regina from Cam's Phoenix School. Hi. Dad's in Kent. Oh, on half term. Fair play. Mustafa, lovely to see you. Oh, in Oman. Fantastic. International. Lovely to see everyone, and nice that we've got a real variety. I think what we'll do is get started. Please do use the chat. There'll be opportunities threaded throughout for you to put some comments and ideas in. I will leave some time at the end of the webinar for anyone to post any questions that you might have. It'd be lovely to have a sort of a conversation at the end. But if you do want to say anything, please just do post it in the chat. Hi, Louise. Okay, so hopefully you can all see the picture that I've got posted on the screen. Last week, I actually went to a funeral, and at the funeral, I saw Sadie. Now, I taught Sadie 10 years ago, and she was in my foundation borderline grade C, as it was then, CD group. And I went up to Sadie. I said, "Hi, Sadie, it's so lovely to see you." She was so surprised that I remembered her and delighted. And I do remember Sadie in particular because Sadie was a visually impaired student. She sat right at the front of the class, although I know she didn't like sitting at the front. And she worked so hard. She found maths really hard. She really wanted her C. She had to work hard, but she got it. I said, "Sadie, lovely to see you. What are you doing?" She said, "You know, Miss," she kept calling me Miss. I said, "Please don't call me Miss anymore." She wanted to call me Miss. Sadie said, I'm now a primary school teacher. And, you know, she said, "I absolutely love teaching maths." She said, "Because I think I found it difficult. I really enjoy sort of, you know, working with kids on their maths." And she said, "Thank goodness I got my maths grade C because it meant I could, you know, pursue that career." It's a lovely story. And I'm sure, you know, you can look at the photo, and those that work in schools, we know what results day is like for those kids that get the results that they need to go on to whatever they've chosen to do. So some of you will probably recognise this number or understand what it is. This is from June 2024. This is the number of Year 11 students who achieved a grade 4 or above at GCSE in the UK. I'm going to flip that now. So this is the percentage of Year 11 students who didn't get their grade 4 or above. So they got a grade 3 or a grade 2 or a grade 1 or not. And when you flip it round, because we think 72.3%, that's not bad, that's quite a lot, isn't it? But when we look at this number, we're thinking actually that's over a quarter of these students who didn't get their 4. Now, we can appreciate why this is important. So many courses rely on those kids getting their 4 or above, 5 in some cases. A-level courses, going on to university courses, apprenticeships, even more vocational courses often do require that grade 4. It's a really, really important grade for these kids to get for what they want to do in the future. I'm going to show you another number now. Now this is the percentage of post-16 GCSE Maths grade 4 plus from this summer. So this is shocking. So these kids who don't get their grade 4 in Year 11 carry on and keep retaking it at college. This is the number that get this summer that got their grade 4 or above, 17.4%. And this is particularly relevant, isn't it? Because this is a signal, and this tells us if these students don't get their maths in Year 11, they are not likely to get their maths. And that is going to prevent them from the option of many, many courses and vocations that they may want to do. So I want you now to have a think about what you feel, and it might be in your organisation or from your experience, what the main issues affecting the achievement of these GCSE Foundation students is. And give it a couple of minutes and just maybe type into the chat what you feel, what's stopping these kids getting their 4s in Year 11. Yeah, gaps of knowledge, quality of teaching, lack of good experienced teachers, lack of engagement or number skills, attendance, disengagement. Let's have one more minute. Just have a think, even if you're writing it down. Confidence, definitely. Yeah. Time to bridge the gap. They're turned off. And I'm sure, thank you. Yes, thanks, Richard. I'm sure that, you know, in your organisations or schools or experience, you will have discussed this, you know, because I actually believe that this measure, the 4 and above measure, is the most important one for schools to focus on. And won't be Progress 8 this year. But I think year on year, I can't think of what a more important measure is than getting as many kids over that grade 4 line as possible. Here are some of the ideas that I had when I thought about factors, and it links in with what many of you have been saying on the chat. And I think this scratches the surface, doesn't it? Because we understand that teaching and learning is a highly complex area. I think teachers are very highly skilled. It's not necessarily recognised how skilled you have to be to teach. And I think particularly kids that are on the lower range in terms of their knowledge, it can be very, very challenging, because that can be for lots and lots of different reasons. So this is the talk this afternoon. What I really want to do is share with you some practical strategies, strategies that, over my experience, do work and do help raise attainment, increase engagement, help motivation and confidence for these kids. This is me, Anne Stothers, 30 years secondary maths teaching experience. You wouldn't believe I was only 32, would you? Author and video creator for HarperCollins, examiner for PiXL and OCR. I work as a specialist for Impress the Examiner, doing CPDs and masterclasses all over the country. I work in schools individually. Those of you who've been involved with PiXL for a while may remember me from PiXL during the years 2011 to 2020. I was an SLE for maths in Enfield. I had 6 years as an assistant head, 10 years as head of maths, and 10 years as head of year in 5 different schools I worked in over my career since 1994. So a lot of experience, and certainly my last post as head of maths and assistant head, and my work as PiXL really focused on the 3-4 borderline and getting those kids over that grade 4 boundary. At Highland School, when I started, the results were around about in the low 60s for 4+, and we, as a team, we worked incredibly hard and rose that to 90% in just over 2 years, which was absolutely fantastic. We kept in the high 80s from then on, but it was always a priority for us. So what I'm going to speak about today is, strategies that I've learned, grounded on my experience, and also a bit about the science that underpins those. So 7 strategies. I'm going to support those strategies with evidence, including some from cognitive psychology, which you may be familiar with. And these are part of my teaching toolkit. So number 1, check students are thinking and listening. Now, I'm sure many of you will remember your first years of teaching. I certainly do, when we would be in front of the class, teach the class, set them exercises. But certainly when I started, there weren't really points in the lesson where I was checking whether the kids were thinking or listening. I might do the odd hands up now and again. I think the mini whiteboard has revolutionised, personally, the way I teach, and a lot of schools that I work with, revolutionised the maths teaching that goes on there. You might be able to spot the error on this board. But I have not found a better way of checking kids are listening and thinking than using these boards. They've got to engage to write something down. Now we know, and the science that underpins this is that it really is pretty obvious, isn't it? If we're not actively engaged, if we're not thinking, we're not learning. So we need to make sure, it's absolutely crucial for all kids, but particularly these borderline kids, the 3-4 borderline kids, that they're actually actively engaged in the lesson. They are thinking. Now, this can look like, expand these brackets on your mini whiteboard. You could throw in a misspelled word. Or one that I really like is to ask the class to write down an answer to a question. It might be an exercise you put on the board, or one that they're doing in front of them, and then pick out the best wrong answers. And there's twofold advantage in this. You pick up their misconceptions, but you also can engender an environment in the classroom where it's absolutely fine to get things wrong. It's how we learn is getting things wrong. And we can all learn from other people's mistakes, and really understanding and discussing mistakes can be a very, very powerful way of getting kids engaged, getting them thinking, and starting to move away from the fact that we're not going to get everything right all the time, and that's absolutely fine. Now, I would thoroughly recommend, when you're doing your lesson preparation, that these checking questions, checking listening, checking thinking, let's call them hinge questions, I'll talk a little bit more about that later, are threaded throughout the lesson, I would say 2 or 3 times, so that at those key points, you are checking that engagement, checking that thinking, checking that understanding. I think another really good use of preparation time is to anticipate misconceptions. And I hope you're all given time in your departments, if you're teachers, to plan lessons collaboratively, because this should include thinking about possible misconceptions that can arise through a certain topic that you're teaching. So here's an example of one of these check questions, hinge questions, check questions. Please answer in the chat. Do we think this is good? Is it sensible? Does it do what we want it to do? What do we think? Can anyone spot a misconception? Yeah. Yeah, thanks, Helena. Thanks, Ray. Yeah, Louise, I agree. So we can definitely see, yes, yes. Thanks, Maria. Thanks, Saida. Yeah. The first one, A, they've added the numerators, added the denominators. And I know from my time as being, yes, thanks, Tilly. It does address those misconceptions. So the first one, they've added the numerators, added the denominators. The second one hasn't been simplified. And D has been simplified incorrectly. So yes, thanks everyone. I think this is the kind of question that's very powerful as INSET or CPD when you're working in your departments discussing topics that are going to come up. You know, are these good hinge questions? Why are they? Can we develop something of our own that's going to target those misconceptions? Here's another one that I don't think is so good. I don't like the language that's used in here. There's no numbers, is there? Just words. So I think for a foundation class, this is one I wouldn't consider using. These are from the diagnostic question site. So do bear in mind that if you do reach for things online, which I think is a really good idea, that you look at the quality of those things and look at think about how easy, what information you're going to get from these questions. Is it going to be useful? This one, I think, not so good. So good quality checkpoint questions, as most of you have said in the chat, thank you, well done, have the most common misconceptions. We want them to be quite difficult to get the correct answer with the wrong knowledge. You know, they've got to know what they're doing. It hasn't got to be too obvious. Need to be quick to answer. And we want the teacher to be able to view the responses really quickly. So multi-choice is a great way of doing that. The kids just need to write down the letter of the answer. Great way to check, you know, and what you'd be looking for is that like 80+% of the kids are getting this right. And if they're not, you might need to have to go back and just discuss any misconceptions that are coming up or any common misconceptions, or you get the kids to explain it to each other. Now, another way of checking listening, checking understanding, and I absolutely love using these worked examples. This is a great book by Michael Persson. If you listen to Craig Barton's podcast, he's been on there. He's an American maths teacher. But these, again, I think are very, very powerful. I'm going to get you to do a bit of work now. This is the kind of steps that he suggests using. And I would present this in silence. And what I find is if you give the kids a bit of a challenge, they tend to step up, most of them. They're quite interested. So a bit of silence doesn't necessarily mean they're not thinking or listening, because then after then you're going to ask them to do some work. So I'm going to give you a little problem to solve now. I'm sure you're having fun having a think of this. Yes. But I'm not suggesting you would put that up for foundation kids. You might do after some work on place value and looking at similar kinds of problems. But these can be used sort of to bridge between you doing some teaching and introductions and the student's own independent practice. So another kind of strategy to get the kids engaged, get them thinking, get them listening, scaffold transition between your work, the I do, we do, and the independent work. I think that's a great question. I just love that. So number two, I'd like to talk about prior knowledge now. We can't presume kids know what they need to know for us to teach a new topic. Even if we've taught them some things before, they don't necessarily, aren't necessarily going to remember them. But the prior knowledge is absolutely key. And I think Daria mentioned it earlier, the thing about a lot of these students who don't have very much confidence, possibly who aren't fluent in their basic skills, are not going to remember necessarily things that we've taught them even quite recently. And I'll talk about retrieval during the session. I mean, I'm thinking of things like we were going to teach something like Pythagoras' theorem to a foundation class. Of course, we're going to want to check that they can square numbers, that they know how to square root numbers, that that's fluent, that they know the symbols, that they're not doubling rather than squaring, and that they can use their calculators properly. So all of that's a lot of pre-knowledge before we actually start talking about Pythagoras' theorem. Now, I've been involved in updating the 5th edition Collins GCSE Maths textbooks this year. And one of the new aspects in these books is prior knowledge recall tests, before each chapter, which I think are absolutely fantastic for ensuring that kids are fluent in what they need to know before we teach them a new topic. And I think that's something that's often missed. So shout out to Collins, fantastic new resource there. And if you do have these books or are ordering up the new edition, then absolutely brilliant. I have to say, I can remember there being a period of time when textbooks were very unpopular, and especially when we had our Ofsted inspections. It's like, don't get any textbooks out, that they can't see the kids working from textbooks. It was kind of a felt that you weren't somehow doing your job if you were putting a textbook in front of a student. But I have to say, textbooks, I think, are such a valuable resource for kids. You've got absolutely everything in there. The best lessons I've seen often are using textbooks, not worksheets. I think people are grabbing worksheets, something online. They're not necessarily fit for purpose. They don't necessarily have all the application or reasoning questions that you'd want. They certainly don't have the differentiation that you might want. But if you've got textbooks in front of the kids, you can direct them to different pages, questions, chapter. You always know that there's going to be problem solving, application. There are some fantastic textbooks out there, and I know they're expensive. And I do realise as well, in fact, I was at a conference on Saturday where I know that a lot of schools are going down the booklets route. And I do understand that it's nice to have the kids to have something to write in, but they take a huge amount of time to produce. It's a lot of photocopying, and the quality, from what I've seen in the schools that I visited, really varies. There's some very good ones and there's some not so good ones. And I think to expect staff to write booklets for kids is a lot. You know, it can very, very time consuming, and particularly if you're changing and tweaking your curriculum year on year, you have to change the booklets, mix things around. So I have to say, personally, I'm in great favour of a textbook. Anything that makes our jobs a bit easier so we can focus on what we're actually questioning, doing in the lesson, rather than preparing resources. Now, going back to prior knowledge, this was a question from one of the papers that I marked this summer, the 1F, the non-calculator EdXL Foundation paper. I'll give you a minute just to read that through. I thought it was a good question, this, a challenging question. A lot of the students were mixing up perimeter and area. It doesn't actually anywhere say the word area. And I think that was the problem. So a lot of students found the perimeter of that shape because probably it looks like a kind of perimeter question. Also, they've got the added work of having to work out how much paint and how much floor that will cover and compare it to the area. So, you know, a very, very challenging question, but one where the prior knowledge of understanding what area is, knowing how to calculate compound area, it's a non-calculator paper, so they've got to be able to multiply that 2.5 by 3 and then by 10. So a lot of number work to do in here as well. So do look carefully on these exam questions, particularly the end ones where the students don't tend to do so well, and have a think about the prior knowledge necessary for the kids to answer that kind of question. The marks allocated, you can see here, are for finding the process to find the area, finding the area, and then the number of tins, and then they have to say yes at the end. But I think a really good question. And if you're teaching area, what a great question to put up on the board. So some of you may be familiar with the work of Daniel Willingham. He said memory is the residue of thought. And this links in with prior knowledge because it's very difficult to learn new content, information, without having something to connect it to that we already know. So schemas in our long-term memory. So if we don't have that prior knowledge, the working memory just gets cluttered up. So that prior knowledge is absolutely key. I think this is a useful definition to remember, that we're aiming to make a persistent change in our long-term memory. That's what one definition of what learning is, or the aim of teaching. Number 3, retrieval. So I think this possibly is the most important tool in the toolkit. We have to use this every lesson to help our kids remember and properly embed what they've learned in previous lessons. If we don't do that, we're going to have to reteach these topics, and you'll know yourself the frustration of teaching a topic and then coming back to it the following year or the following month. It's like those lessons never happened. We need to keep retrieving, and that needs to be really thought through. Here are 3 benefits. And we can use retrieval to start with a little quiz. That could be nice on mini whiteboards or on books, but retrieval reduces cognitive load. If we can embed knowledge, the more we can embed in that long-term memory, the more freed up the working memory will be, and that will mean a reduction in cognitive load. So what we're aiming for with these kids is to keep plugging away, keep retrieving work that they've learned and understood previously. An example, simple example might be 7 times table. Trevor Senior, who I met through Collins, was the senior examiner, I think, for AQA for some time. And he said that if a question has got a 7 in it, an exam question, then it's done really badly. And I think anything to do with the 7 times table, that's the one that the errors creep in on. Obviously, it's prime, and a lot of other tables can be built from other tables, but 7 can't. So whenever I'm taking foundation kids or either tutoring or doing masterclasses, I always, every couple of weeks, I'll throw in 7 times 8 or 6 times 7. I think it's a really important table for the kids to know. There's an example there. Fractions is another one. They forget everything about fractions. That you have to keep plugging it, keep reminding, equivalence, simplifying, adding, subtracting, multiplying, dividing, etc. So that retrieval practice can look like any of these 5 things or anything else that you can think of. It doesn't have to be like a 10-question test at the beginning of each lesson. I think at the moment in many schools, retrieval is a very quick starter as the kids file into the room. Personally, when I'm teaching, I would use up to half the lesson on retrieval. It's such a key part to recap and recall that knowledge. It benefits them going forward. It means you don't have to reteach stuff, but it should be a really big chunk of the lesson. Sometimes it might not be appropriate, but especially if you're introducing new concepts that have a lot of prior knowledge connected to them, you have got to make sure those kids have that prior knowledge embedded so that they can then carry on with the learning, reducing the working memory because they've got it in their heads and they're reminded of it. Couldn't be a maths presentation without a quote from Dylan William. I'm sure that all of you have come across cognitive load theory. I'll put some book recommendations up at the end. But this is so important. This has been around a long time, but it's not really been thrown into the teaching arena until relatively recently. It's so important that we understand the cognitive load that we're putting onto the kids. We cannot expect them to deal with more than 2 or 3 steps at a time. It's just not going to happen. We're going to lose them. If you're interested in finding a bit more about this, it was originally John Sweller who developed this idea. And I said there's a lot of literature and really powerful sort of educational psychology reports which quote this as being very important in terms of being aware of it when we are teaching. And it does all stem from the limited capacity of working memories. And I know myself, I've always thought there was something wrong with me, that when I asked for directions, after, or you turn right at the end of the road and then second left, that's me finished. 2 things and I'm done. Whereas, interestingly, if I'm somewhere I kind of know and someone says, okay, you know the golf garage at the end of the road, turn there and then go along to, you know, the cafe. If it's landscaped or pinpointed with things that I do know that I've got schema for, then I can remember many more directions. That's because I'm using schema, I'm using my long-term memory and not my working memory. And worth, I think, just looking through these 3 before we move on. Because as well as the understanding about working memory, I think that extraneous cognitive load is really important that we kind of think of when we're working with kids. Distractions, we all know how frustrating it is. Somebody comes to the door. I was in Peterborough a couple of weeks ago teaching 120 kids in a hall. It's raining. Took a while to get them settled. Just got them settled. And then someone came in a high vis and said, oh, I've just got to take the register. Took the register 100. I mean, we lose them then. It's a distraction. I think it's very important that when we are teaching, that we keep all distractions to a minimum. You know, we don't want memes on PowerPoints that fly around and stuff. It's a distraction. I wouldn't even put the date on PowerPoints. I would just have the information that the kids need, and that's it. So be very mindful of reducing distractions as much as possible. Now, built in with that is establishing consistent routines. And this is, again, to do with reducing the extraneous cognitive load. I would say that for your foundation kids and for all your kids, really, that you should be having consistent routines in the classroom. They should know what to expect every lesson, because they don't then have to think about, oh, we're doing something different today. Do I need this? Do I need that? They come in, they sit down, you do retrieval, you use mini whiteboards, they're trained up in the way that you want them to use that. You always do some kind of prior knowledge check. You're always going to model. They're always going to do independent learning for a substantial amount of time in the lesson, maybe 10 minutes, maybe 15 minutes. Oh, it's maths. Checks for understanding, and ideally exam questions, application questions at the end. And that's a nice scaffold to have that the kids get used to, and it reduces then that cognitive load. They know what to expect. So another little task. Yeah, you're in maths. You are in maths, but yes, you are. How many letters would you call? So I'm going to show you some letters. How many can you remember? Okay. So well done if you remembered 7, 6. If we chunk it up, have a look and see how much easier that is to remember. And this again links in with this cognitive load. If we chunk things up, if we've got schema, we know what CIA means, we know what BBC means, we've seen ABC before. It just helps us to remember rather than the individual letters. So when you're teaching your maths lessons, think about the fact that the short-term memory is very limited. If we chunk things up, or we're able to link them to existing knowledge, it's much, much easier for the kids to absorb, learn, remember. This is really interesting. I'll just give you a second to read through this. So this is for the people who think, you know, the top set kids are better at maths just naturally than kids in a lower set if you set. Not necessarily true. These chess masters, some research showed that actually in unfamiliar situations, they were no better than the weekend players. And the reason for that was they had more game knowledge in their long-term memory. They knew more chess moves, so we're able to apply that in the games. A lot of this kind of thinking is written about really expertly in Daniel Kahneman's Thinking Fast and Slow. If you haven't read it, it's absolutely fantastic. Really makes you think about biases, how we make decisions, linking it with cognitive load theory. So I really recommend a read. Right, we're on to number 4 now. I'm mindful of time ticking on. Spaced practice and interleaving. So it links a little bit with retrieval. You'll have seen this curve of forgetting before. If we're not recapping basic tables, how to add fractions, how to solve equations, the names of shapes, the names of solids, if we're not recapping that information, then the kids are going to forget them. So I think it's worth spending time in your departments, or if you're working with kids, to make sure that you are developing spaced practice and interleaving, or using resources that mean that they are having to retrieve the information that they learned last week, last year, last month, and that is going to help them to remember it. William Emeny mapped GCSE prior knowledge, 16 out of 20 key concepts were numbers. So I think for foundation kids, there is an argument for, 75% of your retrieval being number. So, reminding how to work with decimals, ordering decimals, there's loads you can do, but map it onto your curriculum. What have you done recently? I think, last lesson, last week, last month, last year is great. As long as you're keeping a record of what you have covered, so that you cover as much as possible. Ofsted said this. So this links in, doesn't it? So, we can get kids to do 100 questions on adding fractions, and they've got it. But actually, next week they may have forgotten that. You have got to keep coming back and doing the same thing. It does help build confidence, that, because it doesn't have to be super easy, but if they're finding success in those retrieval practices, that's going to motivate them for learning for the rest of the lesson. So steep drop in memory right after learning. So when they walk out the door of the classroom, 50% of it's gone already. So by building those recall activities, we can make sure that they are not forgetting, they are remembering, and they are forgetting less the next time they walk out the room. Number 5, EdXL on the Emporium do a bank of 1-marker questions, which are the sort of easy 1-mark questions from the beginning of their GCSE Foundation papers. Now, AQA now have stopped doing multiple choice at the beginning of their papers. They do the 1-markers as well. So I think you could use these for any of the exam boards. What we want to do is we want to, for these kids to get their 4, they need fluency and basic skills. They have got to be able to get the majority of marks on the first third to half of the paper. That is how they're going to get their 4. So that is what you have to practice with them. So the 1-markers are absolutely great. You can just have those in rotation. There's about 20 of them. You can just rotate and keep coming back. They go through all the number, decimal, fractions, basic equations, all that key basic skills, absolutely vital. The shortened exam papers, again, I would use nearing to exam time, maybe nearing mocks or nearing the actual GCSEs. The first 20, 30 or 40 marks of an exam paper, you know, first 10 marks is a nice way to start a lesson, great for interleaved practice, great for retrieval, and it builds confidence. So I've always very strongly believed that that first half of the paper is absolutely key. I know a lot of people don't agree. They get the kids working on the second half of the paper. I don't. I think we all know from our RAG ratings that the second half of the paper, a lot of it is red for these kids that are 3-4 borderline. And of course, we have got to help kids develop expertise for that. But first half, absolutely key. This is the reason why. These are the kind of marks they need. And you need to keep an eye on these boundaries because they have crept up a bit. And when you're setting mocks or tests, make sure that you're setting them at an appropriate level that the kids, that mirrors what the kids are going to have to get in their GCSE exam. So I did hint on this, but I think a lot of kids are a bit maths phobic. They've had such bad negative experience of maths in the past. Their body goes into stress. If you can break that down and give them some success, and it's not making it super easy, it's making sure that they really understand. And so they really understand how to multiply a decimal number by an integer. They absolutely understand how to do that. That's where I think often manipulatives can be helpful if you use them in your schools. Concrete examples, very, very helpful. 2 more to go. Problem solving. Yes, of course, Foundation kids can problem solve, but they need to build expertise. So those basic skills need to be in place. And once those basic skills are in place, then you lead them to unfamiliar problems. And that should be at the end of the lesson or end of the topic. So we can teach generic problem skills, and I'm going to show you a book reference in a minute. But we need to teach them the knowledge, the prior knowledge they need in order to solve those problems. That's the most important thing. One of the best sort of scaffold, you know, to show you a scaffold of how you can teach problem solving, really recommend George Collier's book. You will get a copy of this PowerPoint, so don't worry about making a note of this, but this has got some really good ideas on how to problem solve in mathematics and how to teach that. I love this. If my car's broken, I don't go to a problem solver, I go to a mechanic. It's about expertise. The kids can problem solve if they've got the expertise to do it. I would thoroughly recommend as well to help them develop these problem solving skills, giving them goal-free problems. So take away the question, give them in situation and say, what can you work out from this? It's a lot less intimidating and it really encourages some fantastic maths. And often when we're solving problems, we can kind of play around with it a bit and try different things. So often you can take a GCSE question or a question and just take out the question and give them the information. So really would recommend using goal-free problems to scaffold up to more difficult problem solving. Now, all of these ideas that I'm presenting are things in my toolkit. Some of them you might have used, some of them you might not. Some of them you feel might work very well, some not. But what I'm trying to do here is back up what I'm saying with evidence. And that's why I think somebody said, am I in the wrong webinar? Because I was talking about cognitive load theory, but it does have a massive impact on what we do in our maths classrooms. Just to finish off with metacognition, the more autonomous our kids are, the better they're going to do. The more they can think about their thinking and their learning, the better they're going to do, taking responsibility. So you can do this by, for example, at the end of independent work, giving them a question or a couple of scaffolded questions to help them evaluate, you know, what question was the most difficult? Why did you find that difficult? What do you need to know to be able to answer that question? Or why did you get it wrong? And it might be, oh, I find the ones with negatives difficult because it's more difficult to add a negative than add a positive. It could be that kind of conversation. That could be a think, pair, share, or a class discussion. Autonomy will help the kids. The more autonomous and more confident they are, the more they're going to improve. The evidence for that, some of you may have come across the Educational Endowment Foundation toolkit. They are a charity that commissions tons and tons of educational research and kind of collates it all. So they found that metacognition is the most impactful intervention. So from their research, and this is across subjects, across different age groups, it had the lowest cost and the highest evidence strength as being impactful. So teaching the kids how to revise, how to be autonomous in their learning, take responsibility for their learning. So a lot in there, 7 different strategies. So you will get a copy of the webinar afterwards. And I thought you would be interested, before we go to the chat, if there is any questions, some reading. And since I am not in school full time anymore, I do, especially over lockdown, I do like to read a lot. There's so much fantastic literature out there to do with the science of learning. The How Do We Learn and How Learning Happens are 2 recent books that I've read, very, very insightful. And you'll find that the more you do understand about learning, the more impactful that will be in your practice in your schools. So thank you very much indeed for listening. I'll leave that up on the screen, but so you will get a copy of this. But if anyone has any questions, then if you'd like to, did you want? Oh, the most crucial session, I would say, would be retrieval. You've got to keep coming back and retrieving what you've taught. Retrieval, definitely. But you know, linking that in with prior knowledge checks, space practice and interleaving, all kind of one package of making sure that you're revisiting what you have taught. Right, any other questions? We've got a couple of minutes if there's anything anyone would like to ask. Right, any suggestions for students who struggle with their times tables? Yeah, I mean, I would say, thank you everyone. I would say twos, fives, and tens obviously are relatively straightforward for obvious reasons. I think I would say it's there's two schools of thought. I personally think rote learning and chanting is a great way to learn tables. It's just repeated practice. I think sometimes counters, kids that really struggle, Cuisenaire rods are really good for helping conceptual with tables for multiples of different amounts. So you can get manipulatives that will help with tables. But I think, you know, at the end, particularly when you're working with foundation kids, you know, that chanting and recapping and recalling, that is the way to do it. Keep practice, 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 practice. Oh, did you want me to go back to that slide, Safa? Matching post-it, muddled up, 3 columns, one you always know, one you, yes, yes, like it. Yeah. Thank you, Shirley. Yeah, I mean, that's the thing. All of you working in schools all have a great level of expertise. Um, it's good to be able to share. So if anyone's got anything to share, please, please. Physical items. Oh, making physical items. Yes, I think manipulatives are really, really powerful. I mean, we know that flashcards is an absolutely brilliant way to revise, and kids making their own flashcards. Um, so I think physical, Cuisenaire rods, algebra tiles. It depends if what the kids are used to. It doesn't take time to build up expertise using those manipulatives, but they can be very, very powerful aid to learning. So I think particularly if kids are struggling to get the abstract concepts, then physical manipulatives can be a really useful way to approach learning. Right, so Shirley, you working with adults? Yeah, yeah. They remember their maths teachers. We're famous, guys. Okay, I'm going to say bye-bye. Thank you very much to everyone for your attendance. I hope that's been helpful. So I'm going to stop the uh, webinar now. Thank you very much. How do I actually stop it? Thank you very much. Thank you, everyone. I'm